the central rule for determining whether two compounds will be able to dissolve each other is like dissolves like. There are two types of compounds that we might talk about. Those that have relative charge or full charge, one, or those that have little to no partial charge. If like dissolves like, then what we mean is those compounds which have charge are like each other. They can dissolve each other. Those things that don't have much charge are like each other. They can dissolve each other. But if one thing has relative charge and one doesn't, then they cannot dissolve each other. So as an example of things that have relative charge, we have polar molecules. Those have partial charges on different parts of the molecule. But also we have ionic compounds which have full charges, full positive 1, positive 2, negative 1, negative 2, etc. So an example of a polar molecule, water or ethanol, where ethanol is surprisingly polar, not because it has carbons and hydrogens, but it has OH groups on it, which are quite polar and are able to hydrogen bond. And ionic compounds, sodium chloride. Within nonpolar molecules, we might include things like hexane or decane, things with just carbons and hydrogens. You should be able to recognize that if you have just carbon and hydrogen, those molecules must be nonpolar. But additionally, things like carbon dioxide, which have symmetry around the central atom, and so there is a canceling out of dipole moments, and therefore a nonpolar molecule overall. So, considering like dissolves like, will these things dissolve in each other? All right, so first, consider water. Will that dissolve ethanol? All right, so water is polar, and ethanol is, it has an OH group on it, so it's polar. These two polar molecules are like each other. They both have relative charge, so they will dissolve each other. They're soluble together. What about water, which is polar, and sodium chloride, which is ionic? Both have relative charge or full charge, and so they will dissolve each other. How about water and octane? Water is polar, and octane has just carbons and hydrogens, and so it's nonpolar. One has relative charge, and one has very little relative charge. They're not alike, and therefore they will not dissolve each other. How about octane and hexane? Both have just carbons and hydrogens. They're both nonpolar, so they are alike in that they have little relative charge, and so they will dissolve each other. How about octane and iodine? Octane is nonpolar, and iodine is, let's see, we have the same atom or same element on both sides of this bond, so there is no one end which should get relative positive charge and then one end which should get negative charge. There's an equal distribution of electrons in this bond towards both atoms, and so we're not going to get poles. This is a nonpolar molecule, and so having both of these nonpolar, they should be able to dissolve each other. What about octane, which is nonpolar, and ammonium chloride? We have just nonmetals here. You might say this is a molecule, but wait. Actually, what we have is ammonium. This is NH4+, and we have chloride, Cl-. This is ionic. Will nonpolar molecules, which have very little charge, dissolve ionic compounds like ammonium chloride? No, they're not similar to each other. So we can kind of look at dissolving. You might consider dissolving water together. Yes, that is very happy with itself. It's able to have hydrogen bonds, and which result from the relative charges of elements on water. But also we've got just dipole-dipole interactions. There is a lot of stability when water interacts with itself. And so it is reluctant to break that stability by perhaps having some decane molecule, which is nonpolar, blocking those nice hydrogen bonds and dipole-dipole interactions. Systems will tend to go towards the most stability. They'll tend to shove things aside to make the system more stable. to make it happier, lower in enthalpy. And so instead of oil being dispersed throughout the water, over time, oil will separate from the water and take those kind of broken hydrogen bonds and replace them with hydrogen bonds. When oil is away from water, water is able to hydrogen bond with itself, and so that is more stable. And so oil will not dissolve in water. As another case, consider sodium and chloride. Can they dissolve in water? Well, yes, sodium and chloride, those are ions, and they can dissolve in water because water has relative charge. You can see here that sodium is positively charged. It can be surrounded and stabilized by the relatively negative oxygens of water. Having negative near positive is stabilizing. The system will tend to go towards this configuration. It can last for a while. So sodium chloride is soluble in water, but sodium chloride is not soluble in something like octane, C8H18. Consider where sodium is dispersed throughout octane. Well, though sodium is positively charged, there is very little relative charge on the octane, and so there's very little stabilization that occurs between the ion and the compounds. But if sodium and chloride remains undissolved, remains as solid, then the sodium and the chloride ions surround each other and have nice positive-negative interactions, which is stabilizing, whereas the octane particles can remain with each other and not break those interactions. So it's stabilizing to keep the particles undissolved within the octane, and destabilizing to dissolve it within the octane. And so it is it's insoluble. Sodium chloride is insoluble in nonpolar molecules. Thanks for watching, guys.